Number 8, the quantity of a 7.480 gram organic compounds dissolved in water to make 300 milliliters of solution. The solution has osmotic pressure, right, at 27 degrees Celsius, right? It is, oh wow, we have 41.8% carbon, 4.7% hydrogen, and 37.3% oxygen, and 16.3% nitrogen. We're going to calculate the molecular formula of the compound. All right, so this is an in-depth problem. Let's start diving in. We know what? All right, we can get, I don't know what we can get. We can get osmotic pressure, pi equals IMRT. This compound, it's organic compound. That means almost always I is going to be 1. So we know what the pressure is. We know what the temperature is. I think we can plug this in. So 1.43 atmospheres equals 1 times molarity, which we're looking for at the moment, times 0.08206 liters atmospheres mole Kelvin, times 27 degrees Celsius. So if you add 273, right, that's going to be 300 Kelvin. Right. So we got 3 sig figs. So M then would be our 1.43 divided by our R, 0.08206, and our 300 Kelvin. So I get 0.058087578195, and we have 3 sig figs for this, so 0.0581 molar compound. Excellent. Now we can figure, I know how much I have, and so we have 300.0 milliliters, which is the same thing as 0.3000 liters of our solution. And if we multiply that by, for every 1 liter, we just found we have 0.0581 moles, right? So 0.0581 times 0.3, I get 0.01743. So that's 0.0174 moles of our compound. Now we don't mean grams in our compound, right? Our compound is 7.480 grams of our compound. And if we divide that by our 0.0174 moles, we get a molar mass. 7.480 divided by 0.0174, I get 429.8850574771. And 3 sig figs, 430 grams per mole. Excellent. Wow. Okay. Now, this other stuff's old, right? We know we have 41.8% carbon, 4.7% H, 37.3% oxygen, and 16.3% nitrogen. All right, so there's more than one way to do this. I like to do it this way. And the way I like to do it is assume 100 grams. I like to assume 100 grams. So we have 41.8 grams of carbon, 4.7 grams of hydrogen, 37.3 grams of oxygen, and 16.3 grams of nitrogen. Then we got to go to moles. So we're going to divide all these by their molar mass. So 12.01 grams per mole, 1.01 grams per mole, 16, and 1401. All right, so for carbon, 41.8 divided by 12.01, I get 3.48 moles of C. 4.7 divided by 1.01, I get 4.65 moles of H. 37.3 divided by 16, I get 2.33 moles of O. And 16.3 divided by 14.01, I get 1.16 moles of N. All right, so now we divide by the smallest, which is 1.16, to get whole number ratios. So 3.48 divided by our 1.16 gives me 3. The 4.65 divided by the 1.16 gives you 4. The 2.33 divided by 1.16 gives us 2. And, of course, 1 for nitrogen. So our empirical formula, C3H4O2N. So that's what our empirical is. Now, our empirical has a molar mass, right? So 12.01 times 3 plus 1.01 times 4 plus 16 times 2 plus 14.01. That gives me 86.08. Now, we found out our molecular compound has a molar mass of 430. So 430 grams per mole is the molecular. So if I divide that by the 86.08, we would get what? 430 divided by 86.08, I get 4.995. Which is 5. So 5. So I got to take my empirical and multiply it by 5 to get the molecular. So that means the molecular would be C15, H20, O10, and 5. Whew, that was a good one. Let's recap. What do we do here? All right, we took our organic compound. We took the osmotic pressure. So we used the osmotic pressure formula, 1.43 atmospheres. We knew I was 1 because organic compound. Found the molarity, got R, and got the temperature in Kelvin. So once we found the molarity, we had the amount of solution. We just made it liters, and times the molarity gives us moles. We had the grams, all right? So grams divided by mole, molar mass. So we got the molar mass of the compound. Then, this was just like empirical molecular formulas in Chem 1, where you have your percents of your elements. Assume 100 grams, right? So you make them grams, or makes it nice. Divide by the molar mass to get moles. So we're always going grams to moles. And then once we have the moles, we divide by the smallest to get the whole number ratios, and they were all whole numbers, so we found our empirical that way. Once we found our empirical, we knew how many empiricals went into the molecular, 5. And so we took our empirical times 5 to get the molecular. That was a good problem. Let me know if you have any questions.